This one is going to lead us right into our lesson today. This is the last lesson of the unit. It is over perimeter and area ratios. You've already learned this lesson in the similarity unit, so it's just going to be a review today. Yay! 7, which one is it? So to do the area of number 1, you would do 24 squared for this one. And on this one, you would need a height. When you take 24 and you cut it in half, you get 12. And the height of this one is 16. So it would be base times height divided by 2. 768. Perimeter of number 2. Perfect. 56. Then when you're getting the area of number 2, you have to draw the height in. This is 6, and that's a triple. 6, 8, 10. So the height is 8. So for that triangle, you'll do base times height divided by 2. And for the square, you'll do 12 squared. Area of number 2, 168. No. There we go. That one's right. 192. 12 times 8 divided by 2 plus 144. Okay, so why did we do this warm-up? Well, first, we did it because we're in the area and perimeter unit. But second of all, it leads us into the lesson. Good observation, V. Let's talk about that real quick. What is the scale factor from the first shape to the second shape? How do you get from 20 to 10? How do you get from 24 to 12? The scale factor is 1/2. What is the ratio of the perimeters? What's 56 divided by 112? It's 1/2. So wait a minute. So the ratio of the sides is 1/2, and the ratio of the perimeters is 1/2. Because sides are one-dimensional and perimeters are one-dimensional. Now, V was saying you can't just half the area, guys. Some of you took 768 and you're like, I can shortcut this. I'm just going to divide it by 2. But the areas are not halved. What's the ratio of the areas? It's 1/4. And the reason is because area is two-dimensional and sides and perimeters are one-dimensional. So in that list that I put at the top, it's 1D, 1D, 2D. Where did the 4 come from? You take the scale factor, 1/2, and you square it. You get 1/4. Okay? So that's the lesson for today. I'll let you write it down. That's literally what we just did in the warm-up. If you have two figures that are similar, they have to be similar. If they're not similar, throw it out the window. If you have two figures that are similar, the ratio of their sides is A to B. The ratio of their perimeters is A to B. The ratio of their areas is A squared to B squared. Doesn't get much more simple than this. Ooh, good question. Quan is asking, scale factor versus ratio. Please explain. That's a good question. If I say I want the scale factor, you always have to put second over first. Scale factor has a certain order. It's what number gets you from the first to the second. But a ratio, if I just say, tell me the ratio of the sides, you can put that in either order. So a ratio, you could have said 1 to 2 or 2 to 1. So in a ratio, if they don't specify, then the order doesn't matter. But in a scale factor, it's always second over first. The order does matter. Did I explain that? Given the following squares, find each ratio. We're going to fly through these because it's going to be really, really straightforward, really basic. What is the ratio of the sides? Now, they didn't tell us what order to put it in. Some of the ones on your homework does tell you what order to put it in. This one doesn't. So we can do second to first if we want. The ratio of the sides, 7 to 4. The ratio of the perimeters. Now, are you going to sit there and find the actual perimeter? No, that's what this lesson is all about. It's about skipping steps. So you don't actually find the perimeters. You know that sides are one-dimensional and perimeters are one-dimensional. So if the ratio of the sides is 7:4, then when you reduce the perimeters, when you put those in a fraction and reduce, you're going to get 7:4 again. And the ratio of the areas, a squared to b squared. That's all there is to this. Not bad. Next one. Given the similar hexagons, find each ratio. Since they're similar, this problem just got very easy. You don't even need to know that these are hexagons. Hexagon is actually not going to make its appearance in this problem at all. All we care about is the dimension that we're in. Now, what are we given? Values that are 1D or values that are 2D? This gives you a hint right here, and this right here gives you a hint. We were given areas. Those are two-dimensional. So if I want to know the ratio of the sides, how do I undo 2D? What's the opposite of squaring something? Square rooting. Very good. So the square root of 169 is 13. The square root of 100 is 10. So the answer is 13 to 10. You could also put 10 to 13. The ratio of their perimeters. Are we actually finding a perimeter? No, absolutely not. We know that perimeter is one-dimensional. And finally, the ratio of the areas that was given to us, so we're not doing any work here. We're just grabbing those from the problem. Did we use apothem times perimeter divided by 2? No, because these are similar figures. Now, when we have a problem like this, we are used to setting up a proportion and cross-multiplying. Sometimes you can cross-multiply right away, and sometimes more work needs to be done. So you need to check your dimensions. Let's see. If I put second is to first as second is to first, now 15 and 12, those are sides. Sides are 1D, so I'm going to put a little 1D bubble above it. 15 and question mark, those are perimeters. Even though you're adding things up, perimeter is still one-dimensional. See how it's just inches and just inches? Perimeter is you're not coloring anything in, you're outlining. So it's 1D, so this is also 1D. When the dimensions agree, you can do what you've always done in math for forever. You can just cross-multiply. So this problem we're just showing you, this is one where you're allowed to just cross-multiply. 115 times 12 divided by 15. So the perimeter of the other one is 92. Did I actually have to find the missing side and then add up all the sides? No. The reason is because they're similar. Now let me show you one where you can't do that. Second over first equals second over first. On the test, some of my students are going to do, I'm waiting for the writing to show up. Some of my students on the test are going to do 45 times 15 divided by 9. They're going to put 75 and they're going to get this problem wrong. The reason is because these ratios do not agree. 9 over 15, those are sides, so those are one-dimensional. 45 over x, those are areas, so they're two-dimensional. Those two ratios are in a fight, and you cannot cross-multiply fighting ratios. So you need to make them agree. Now, what are they going to agree on? Are they going to agree on 1D, or are they going to agree on 2D? It's always where your answer lies. My answer lies in the 2D column. So everybody's going to convert to 2D. 2D wins this fight. So all you do is literally square the 1D things. Now everything is 2D. The left is 2D, the right is 2D, and now you can do your happy cross multiplication. 15 squared times 45, enter, divided by 9 squared. Final answer, 125 centimeters squared. So you're not allowed to cross multiply until you're in the correct dimensions. 2 more problems. Lauren ordered 2 pizzas. The diameter of the smaller one is 1/4 the diameter of the larger. What can you conclude about the surface areas of the pizzas? We do this at my house. I make little mini pizzas for my daughters, and I make one big pizza for me and my husband because they like to decorate their own. So theirs is probably maybe 1/3 or 1/4 the diameter of mine. But when we're spreading cheese out in the middle, does that mean they get 4 times less cheese than the larger one? So, diameter is 1D. This is 1D. It's asking about the surface area. Keyword is area. If you take the diameter and you divide it by 4, what are you supposed to do to the area of the pizza? Not divide it by 4 like in the warm-up. Remember, you couldn't just divide the area by 2. You have to square it to make it 2D. So what's true about the areas? What's the answer? The surface area is 1/16 the surface area of the larger. You have to square it. So just be careful. You can't compare diameter, which is 1D, to area, which is 2D. Last problem. It's springtime, so we're planting tulips in our garden. We have a 2x5 garden, and we're going to plant 30 tulips. Notice I shaded it in because when you're planting tulips, you're going to fill the garden up. That's an area. That's not a side. How many tulips would we plant in a 4-foot by 10-foot garden? Now, what did we do to the sides? 2, 5 became 4, 10. We doubled the sides. So if I planted 30 in this one, am I going to plant 60 in my larger one? No, because these are sides. The sides were multiplied by 2. But tulips we're filling in, that's area. So what do I do to 30? I don't multiply it by 2, I multiply it by 2 squared. I need to make it 2D. So the answer is not 60, which some students are going to choose. The answer is 120 because I doubled the length and I doubled the width. Times 2 times 2, that's really times 4. Okay, the lesson's over. Start on your quiz.